Hey, what is up everyone? In this video, I'm going to be talking to you guys a little bit about multiprocessing, threading versus just running your code synchronously. And I will show you an instance where sometimes it's more worth it to just run things synchronously. Now I'll explain a little bit more about that in a second. For the sake of this video, let's go ahead and explain what our script is going to do, and then I'll get into everything. So I've written a script that takes a CSV file like I have over here. This CSV file for every line just has two things on it, two entries. So there are 500 lines, and what this script does is it just creates 500 QR codes. So the name will be the name one, and the content of the QR code, meaning when you scan it, you will get the content. So let's say for the first one, the name of it will be name one, and the content when you scan it will be content one. And like I said, it just does that 500 times because there are 500 entries on the CSV file. So it does that. Let's just go ahead and get into it. Over here, the first line of the main, what it does is it'll just take that CSV file and put it into a dictionary. It uses pandas to do that. We're going to do this synchronously first. You can see here that we have a for loop, and this just does it 500 times. It will create a QR code. It'll do the make code function with the key and the value. So when we run this, this should synchronously, meaning one after the other, create 500 QR codes. Over here, these last two lines of the script will just calculate how much time that took, just so that we can see it in the console window and get an estimate for which one has the best performance. So I'm just going to go ahead and run this. You can see right away it starts up. You can see it starts creating the QR codes right away. And it should do that 500 times. You can see it just finished, and it took 8.69 seconds to do. So if we run it one after the other without any threads or without any multiprocessing, it just will take 8.69 seconds. So that's how it does synchronously. Now I'm just going to delete all of these QR codes because we don't need them anymore. Now I'm going to bring in this window. This window is taken from my Mac's activity monitor. We can just see the performance of all the cores, or what all the cores are doing. This is a 6-core Mac, but for every core there is a virtual core, so that's why there are 12 cores here. And when we run it the multiprocessing way, we can actually see that we in fact are multiprocessing, because we're taking advantage of all the processing cores. And let me just explain for a second what I'm doing here for this script. So over here we have a for loop that what it does is it just creates 500 instances, 500 processes. It just names them all P. It starts every process and then just appends every process into a list or an array of processes. Once it's done with the first loop, we do need to use process.join just so that the code doesn't keep going or doesn't continue and calculates how long it took before we end the program. So we do process.join, and multiprocessing is usually used for when we're using some sort of processing intensive task. Now in the case of the PyQR code module, what we're actually doing is we're just using the processor to make a QR code. We're not calling any sort of API. We're not waiting for the network to refresh, or we're not calling anything from the network. We are actually just using the processor. So it should be interesting to see what happens over here in the cores, because we're going to create 500 processes, and we're going to use all the cores for that and see exactly how much time this takes. So we're just going to go ahead and run it. And right off the bat, we can see that the cores are being taken advantage of. You can see that this jumps, it spikes up because we are using all the cores. And over here in the console window, we see that they're not actually starting so quickly. You see it started right now just creating the QR codes, but it actually took a couple of seconds. Now this is understandable because when we create a new process and start it, it actually does take a bit of time to start a new process, because lots of information is kept in the process. It has a big PCB block, if you know what that is. If not, that's fine. And it does take a bit of time. So off the bat, you can see that it's still going. It's creating QR codes, and you can see that it took 51.48 seconds, which is a lot of time compared to that just a little bit over 8 seconds of running it synchronously. So that's just to show that sometimes you don't really need to use multiprocessing, and sometimes it's not really worth it. Sometimes it is worth it when you're running much heavier tasks, and doing things synchronously will kind of is basically not effective at all. But in this case, we're using the process, and we can see that if we run it synchronously, it takes a lot less time. So that is something to take into account. And now I want to show you what it's like when we use threading. Now threading is more efficient than multiprocessing, but it's normally used when we're doing I/O based tasks. We're dependent, let's say, on the network or on user input. Let's say we're calling an API, and it takes some time to call an API. So while we're waiting for that one, we want to run the next one. So it's not really meant for processor heavy tasks. But we'll see how it does in this case. Multiprocessing took 51.48 seconds. Let's see how threading does. Now, if we want, we can take a look over here at the cores. You can see it's not really doing that much to them because it's not multiprocessing. It's not taking advantage of all the cores. But you can see that it took 8.92 seconds. Now, I don't remember the value of when we did it synchronously, but I'm pretty sure this is a bit more because it takes some time to create a thread. Not as much time when we do it synchronously. It doesn't have to create threads, so maybe that's why it does it faster. But we can see in this case, to prove a point, it's not always the most effective to use multiprocessing or to use threading. Sometimes it's better just to go the old way of doing things synchronously, even when we do have a processing intensive task to do. So if you want to check this out for yourself, I will leave a repository to this code in GitHub, just so that, if you want to go ahead and look at it for yourself, see what it's doing and run it yourself. That's basically it. I hope I proved my point. I hope this video was understandable. If it was, feel free to subscribe. It does help the YouTube algorithm, and have a great day.